Hey everybody, welcome to Algebra 1-2, Section 9-3, Solving Quadratic Equations by Graphing. So we start off this chapter talking about graphing quadratic functions. Today we're going to bridge the gap between graphing quadratics and solving quadratics. All right, so by the end of this lesson, you should be able to solve quadratic functions by graphing. You should be able to double check your answers to a quadratic equation. And you should be able to recognize that there's 2, 1, or possibly 0 solutions to a given quadratic equation. So previously we've talked about quadratic expressions, especially in Chapter 8 when we talked about factoring. A quadratic equation is an expression is something that has the biggest exponent of 2 and is usually in this format, ax squared plus bx plus c. All right. So here's an example, 2x squared minus 12x plus 16. So if we talk about a quadratic equation, that changes things up a little bit. A quadratic equation has to have an equal sign in it. So ax squared plus bx plus c equals 0, that's an equation. So if I were to apply that to the previous thing, so 2x squared minus 12x plus 16 equals 0, that's a quadratic equation. And as soon as we put the equal sign in there, all of a sudden our goals change for the problem. So our goal now is to figure out what x is. Before it was just about graphing, okay? So now we want to figure out what x is. What could I plug into x to make that equal 0? So we're going to learn several methods over the course of the rest of this chapter. So we're going to talk about solving by graphing, which we're going to do today. And that's going to bridge the gap between graphing, which we've talked about, and solving. We're also going to learn how to solve by using square roots, by factoring, and by using the quadratic formula. But those we're all going to do in the second part of the chapter after spring break. So today we're just going to focus on solving by graphing. So let's take that equation, 2x squared minus 12x plus 16. But whenever we graph, we compare x and y. So what I'm going to do is I'm going to make sure all my numbers are on one side, zeros on the other, and then I'm going to replace that 0 with y. Okay, so now that it has both x and y, now I can graph. So let's go ahead and flip this around so it looks a little bit more familiar. Let's put a graph up there. And let's go ahead and start to graph this equation. So when we start to graph, we need to know the axis of symmetry and the vertex. So when we start doing the axis of symmetry, of course, we use x equals negative b over 2a. So let's go ahead and take those a and b values and just kind of plug them in there. So negative 12 over 2 times 2. Of course, negative 12 is a positive 12, and 2 times 2 is 4. You divide that out, and you get x equals 3. All right? So now I know where my axis of symmetry is. So I can go ahead and put that vertical line there. And I know my vertex is on that line, but let's figure out where. Let's take that equation, and let's take that 3 and plug it in for x. And then let's just work it on out. Let's square that 3, and then go ahead and do our multiplication, and then our adding and subtracting, and we get y equals negative 2. So I know that our vertex is the coordinate 3, negative 2. So let's go back to that graph. Let's go ahead and plot that point. And now let's go ahead and figure out where the rest of the points go. So let's go ahead and take our table, put our vertex right in the middle. And then for my x values, I'm not going to use the negative 2, negative 1, 0, 1, 2. Instead, I'm going to pick 2 numbers directly below 3, so 2 and 1, and then 2 numbers directly above 3, so 4 and 5. So now let's go ahead and take those numbers one by one, plug them into the equation, and see what we get. So if we take, let's do 1 first. So we plug in 1, work it on out. For the sake of time, I'm not going to go into how we do each step. I'm pretty sure you guys have figured that out at this point. But when I plugged in 1, I got 6. So let's do the same thing for 2. Plug in 2, work it on out, and you get 0. Let's take 4, plug it in, work it on out, and I get 0. And then let's take 5 and plug it in. And some of you might see a pattern here and might be able to predict what happens when we plug in 5. But we work it on out and we get 6. So that's our table. That's what we're going to use to graph these points. So let's go ahead and put those points on the graph. Let's connect the dots. And now we have our graph. Once we have our graph, we're ready to find the solutions. And as we've already talked about, the solutions have several different other vocabulary terms associated with it. So there's the solutions, the roots, the zeros, the x-intercepts. They all mean the same thing. So all I have to do is take a look at my graph and see where's the x-intercepts. So they are right there and there. Those are my x-intercepts. So those are my solutions. The coordinates 2 and 4, or more specifically, 2, 0 and 4, 0. Now I said that I want you guys to be able to check your work because here's what I'm going to do. If I take the 2 and 4, I've already done the work. I've plugged in 2 and I got back out 0. I plugged in 4 and I got back out 0. So this chart is confirmation that 2 and 4 are the numbers that I could plug in for x and get 0 as an answer. All right, so let's go ahead and do a few examples and see how this works out. All right, so here's an example problem. Y equals negative 2x plus 8x minus 6. So to solve this, let's go ahead and first figure out our axis of symmetry. So I'm going to do negative b over 2a. So that is negative 8 over 2 times negative 2. So negative 8 over negative 4, I get x equals a positive 2. So I can go ahead and I'm going to draw a line. All right, so now I have my axis of symmetry. Let's go ahead, take that 2 and plug it into the equation. Let's get a different color here. So y equals negative 2 plus 8 minus 6. Just to kind of keep it from all blending together, let's use different colors. All right, so let's work it on out. Square that and I get 4, and then 4 times negative 2 is negative 8. Plus 16 minus 6. So I get 8 minus 6, which is 2. So that's my vertex. It's 2, 2. So I will put that in the chart. And then I'll pick numbers that are less and bigger. All right, so let's go ahead and start plugging these numbers in. And for the sake of time, I'm not going to go through painfully step by step. I'm going to try to do these mentally as much as I can. I don't suggest you do that, but I'm the teacher. I can do that. So if I plug in 0, I get negative 6. If I plug in 1, I get 0. If I plug in 3, I get 0. And if I plug in 4, I get negative 6. So if I plot those points, negative 6, 0, I already got my vertex, 0 and negative 6. There's my parabola. And I knew it was going to be upside down already because my a value is a negative 2. So that just kind of confirms that we've done something right here. And if you're not getting that U-shaped value, you might want to reevaluate what you did to get your axis of symmetry, your vertex, any work that you've done, because you should be getting that nice, easy U-shape. So my solutions, x equals 1 or 3. Or we said 1 and 3, that's fine too. Okay, they both work. So those are my answers. All right, let's try another one. All right, so if I want to find my axis of symmetry, I'll do negative 2 over 2 times 1. And so I get positive 2 over positive 2, so I get x equals 1. So let's draw that. Go to +1. All right, let's find our axis or our vertex. Let's take that 1 and plug it in. So I get y equals 1 squared minus 2 times 1 plus 1. So 1 squared is 1. Negative 2 times 1 is negative 2 plus 1. Add that all up, and I get 0. So my vertex is the coordinate 1, comma 0. So now I'm going to pick two numbers below 1, so 0 and negative 1, and then two numbers above 1, so 2 and 3. And I'm going to mentally figure these out. So if I plug in negative 1, I get 4. If I plug in 0, I get 1. If I plug in 2, I get 1. And if I plug in 3, I get 4. So when I plot those, negative 1, 4. Oh, that's even off the chart. 0, 1, 1, 0, 2, 1, and 3, 4. So there's my nice, easy U shape. Okay, so if I'm solving this, where does it cross the x-axis? Well, it looks like in this case it only crosses at one spot. So my solution to this equation, the only number that works is x equals 1. So an important thing I want you to see here, on the last problem, we had two solutions, but it's also possible for that parabola just to come down and hit the x-axis at one spot. So we have one solution. Let's do one more example and wrap this up. All right, let's go ahead and figure out our axis of symmetry first. So I'll have negative 8 over 2 times 1, which is 8 over 2, which is 4. So I will go ahead and make my axis of symmetry on the line x equals 4. And then I'll take that 4 and plug it into the equation. So y equals 4 squared minus 8 times 4 plus 17. And so I get 16 minus 32, that's a negative 16. And then plus 17, I get 1. So my vertex is the coordinate 4, 1. So over 4 and up 1. All right, let's pick two numbers below 4. So 3 and 2. And then above, so 5 and 6. All right, if I plug in 2, let's see, 4 minus 16 plus 17. So I get 5. That doesn't look like a 5. If I plug in 3, I get 9 minus 24. I get 2. If I plug in 5, I get 2. And if I plug in 6, I get 5. All right, so if I plot those points, 2, 5, 3, 2. I already got my 4, 1, 5, 2, and 6, 5. Got my nice, easy U shape there. So now to figure out where what the solutions are, let's just see where it crosses the x-axis. And in this case, that parabola comes down and doesn't even touch. So the answer to this is there's no solution. Okay? So hopefully you guys are getting decent at graphing parabolas. Recognize that they can have two solutions, like we did down here. It could have one solution, like we did over here. Or it can have no solutions, like we did up here. All right? If you guys have any questions, please feel free to email me, ask me questions in class, and I hope you have a good one. I'll see you real soon.